Welcome to August 28th LeetCode Challenge, Maximum Profit in Job Scheduling. We have n jobs where every job is scheduled to be done from start time to end time at index I obtains a profit of profit I. You're given the start time, end time, and profit arrays. Return the maximum profit you can take such that there are no two jobs in a subset with overlapping time range. If you choose a job that ends at time X, you'll be able to start another job at time that starts at time X. So let's see, we have a start time of this array, which are numbers, integers. We have an end time, which are also integers. So it's just, and then we have a profit as well. So we want to maximize the profits. So we could assume that, yep, right here, the length of start time, end time, and profit, they all have the arrays, all have the same length. So that's good. So that means that each index I corresponds to the same time frame, right? So for instance, you have time 1, index 0, at end time is 3, so index 0 here. That means that the shifts or the job time scheduling will start from 1 to 3, right? And then if we start from 1 to 3, we know the profit is 50, and we'll want to maximize that. So if we were to plot all the start time and end times such that they're not overlapping, we get all these kind of together, and we want to choose the ones that maximize profit, which would be 50 plus 70, right? Because it maximizes the entire range. And exactly what it describes here. And let's see, we also have another one right here. So we see how even maximizing the entire range is not a prerequisite, because for this one, if we have ranging starts from 1 to 3, then 3 to 10, which would take 120, 10 plus 20, that's not the maximum profit, because the maximum profit is actually the time frame that includes 70 and 60, because if we add those together, it equals 150, which is more than the maximum time frame that covers the entire lot. So we want to maximize this window of opportunity, and that the maximum time is not always indicative. So we want to basically iterate through it and find which one of these combinations that were not overlapping that will give you the maximum profit for the time frame. Likewise this, right? If we have an overlapping of all three of them together and you only have at least one time frame, you want to maximize the profit. It doesn't matter which time frame it is, as long as it is maximum profit. So let's look at the hints here. So you think of dynamic programming. So that's the solution I think we're going to do. We are going to sort the elements by starting time and then define a DP array with maximum profit taking the elements and the suffix at the start of I. Yep, we're going to do that. And we're going to use a binary search for the upper and lower bound to get the index of the dynamic program transition. So that's exactly what we're going to do. So first thing I'm going to do is sort the jobs. So I'm going to sort it like this. So jobs will be sorted such that it is in a list zipped with the following. We have start time, end time. I want to zip all those together in a nice, neat fashion, and profit. So we have the jobs are now sorted into a list zipped with time, end time, start time, end time, and profit. Next thing you want to do is develop redefine the start time. So I'm going to redefine start time as, or it doesn't have to be start time, it could be, let's see, call it time, or range, no, time. So this is the time frames that's going to be in. So, and that's going to be in an array of I. It's going to list comprehension for I in jobs. For each time frame, or each job time frame, we're going to define it as a list comprehension like that. We also need to know the length of the jobs as well, how many jobs we have. We want to develop a dynamic programming array, initialize to 0 times n plus 1, right? Because we're taking in index 0 as well. N plus 1. All right. So we pretty much define all of our variables that we need. We redefine jobs as sorted, as developed, developed in the hit. We developed a dynamic programming array. We got that. Now we're gonna need to type up a binary search algorithm. It's gonna be a nice short one. It's actually gonna be a for loop here. So for let's say k in the range of n minus 1. So we're going to go in reverse here, minus 1, minus 1. So we're going to go reverse by 1. And then reversing the range for finding each element k, we're going to define a temporary dynamic programming max, right? Go a temp max, let's call it that, right? I'm going to use the bisect function. It's kind of built in, bisect left, I think. Yep. And then for time and jobs k at index 1. So we want to bisect the time frame that we take with the jobs at k at index 1, and to redefine that, and then we're going to update the dynamic programming array at position k to be the max, right? You want to keep track of the max that we have, and what's the max of? The max is going to be the jobs at index k at position 2, because it's the job afterwards. Erase that. Plus the dynamic programming array at temp. And then we want to take that, either that's bigger, or we take the max of k plus 1, which is bigger. And then we want to return our dynamic programming array at index dp index 0, as always. Alright, let's test this out and see if this works. Submit. Alright, accepted. So imagine we take basically a job with number k. What can we take next, right? So what we need to do is wait until the job is finished and look for the jobs basically at jobs at k1 position. Define which jobs start more than programming array k plus 1 index. So we don't take a job k if we don't need to take the job k at all. So then we need to basically take any job without k plus 1 without restrictions. So notice that we also start from k, where k is actually equal to n minus 1 position, because we know that k equals to 0 is going in the opposite direction. So we need to basically find the answer at dynamic programming array at k, right? So time complexity is big O of n, which is for the for loop, and log n, because the bisect left is a log n function. Space complexity is big O of n, where n is the size of the length of the profit length, end time, or start time, because we make a dynamic programming array of that size. Alright, that's it. Have a great day, guys.